Hello, thank you for coming, and my name is Aleksandr Tavgen. I want to talk about observability, what it is, and want to cover some pitfalls and anti-patterns on this way. About me, I have more than 19 years of professional experience. Have a fintech and data science background, and worked in different fields from programming microcontrollers up to SRE teams, and solved some specific problems in operational scale. So I want to make some little introduction around that. Before the start, I want to make some introduction what observability is, because there is a lot of jokes around that, like let's DevOpsify monitoring, or if you, for example, I am engineer software who create for you monitoring pipeline. Okay, take $10,000. I am an architect who create observability. Shut up and take 200,000. So what it is? Actually, if we talk about good old monitoring, then usually it is some sort of probing, of assuring that some system is up and running, and observability is much higher, because you need to integrate information from different sources. Or sometimes we can talk about the so-called pillars of observability, where you have metrics, you have traces, and you have logs. And actually, everything is usually start with a problem. And if we talk about some large enterprises, companies, then usually there is a huge amount of different solutions, especially if we talk about some large multi-product enterprise who has different teams in different cities, who developed some sort of technology or solution on their side, and it's quite complex, and it's almost impossible to have a centralized view, centralized operation, and we'll talk about that as well. And if we talk about some small enterprises or startups, then main question here is about how to choose some technology which is right, which is fit for the tasks, for the problems. And actually, a lot of companies have failed this way. There is a lot of anti-patterns have developed in this field, and we will talk about that. If we take a look in some example of multi-product large enterprise, then we can see that we have usually a lot of independent teams. So we have agile, so the teams are free to choose some technology or technology stack for solving their issues. And it means as well that teams are also responsible for some sort of monitoring or visibility around their system. And in that case, it's very hard to have some central picture, because, again, you need to manage a zoo. And it's hard to make changes, because, again, if you have an independent teams, if you have a freedom to choose, then at the end of the day, you will face with a huge amount of different solutions which you want to operate. And the common anti-patterns on this way is, as usual, it's very tempting to record everything just in case. Like, okay, let's set up something, for example, Prometheus, and start to push everything, because we don't know, maybe we will need something in the future. And it leads to a proliferating amount of metrics or data. It leads to exponential growth of the complexity or operations, and nobody actually understands so huge amount of metrics. And engineering endeavor for managing, maintaining such kind of system is also quite large. For example, this is quite famous antipattern made by Uber. You can see their monitoring solution. They have more than 9 billion metrics. They have more than 1,000 monitoring instances. And you can see it's quite ineffective. Why? Because they want to substitute logs with metrics. And even, for example, there is one case from Estonia. There is one startup which is also faced the same problem. They just started to build a monitoring solution around their business logic, and after a year and a half, they faced with a huge amount of complexity. They have a problem that nobody understands large amount of metrics a bunch, and they also tried to substitute so-called logs because they stored some unique identifiers in metrics and so on and so on. Uber also makes this antipattern right. So actually, you don't need to have a 9 billion metrics. So if you have such amount of data, such amount of metrics, if we talk about the metrics, then if you have such amount, then probably you are wrong. And another problem which come from this antipattern is that if you have a large amount of metrics data, then it leads to unusable dashboards. So you cannot understand in an easy way what's going on. It's almost impossible, for example, for a human being to observe or to maintain, to check 9 billion metrics. And quite often it looks like spaghetti. And quite famous example here is GitLab dashboards. GitLab is an open company which is famous for its transparency. So they have Grafana, operational Grafana, which is open for everybody. It's just a small piece of dashboards. And this is just one small piece in this menu. So every single menu has this huge amount of spaghetti. So sometimes it looks like this. And if you have a dashboard spaghettification, then it's almost impossible to have a quick understanding just watching this. Actually, dashboards are very useful, but when you know where and when to watch. And in this case, our brain is more effective into recognizing visual patterns, for example, because if you have some observability solution, for example, oriented on logs, then you need to have to query data, and querying is needs much more cognitive effort in that case. And here is we can see that metrics is actually a so-called low resolution level of our system dynamics behavior, and trying to set this resolution higher means that usually companies begin to duplicate logs with the metrics data. They need to have some synchronization on this side, and the metrics never should replace logs. And in that case, you don't need even millions of them. Why we need why talk about the metrics in the first place? Because as I said, if you have some low resolution picture of your system, then you can catch some problems quite fast. And then other sources of information, such as logs and events, can give you information about what's going on. Let's talk. Yeah.
May I metric record from the application record at all. I mean, like, I have a good idea how do you create a log record, like on the application layer. But how do you make your stack to instrument a metric record like from within your application?
It's a good question because there is different. I will also talk about that because there is like a different layers about metrics data. If we talk about some infrastructure level application or some KPI. So let's start with another topic. It's about incidents. Incidents is something that has impact on your business, on your operation, and they're quite expensive. You can see here that there is quite large numbers related to average cost per minute for service outages and average cost of data center outage. But more important is that incidents has credibility costs, which is much more important. There is another research from Statista.com, cost of an hour of downtime last year, and you can see that average is about $300,000–400,000. In case of our company, I can say that we're also somewhere in this area. And if we talk about the causes of outages, then usually it's some change, some network failures, bug, which is also related to change because bug should be deployed as well into production. Some human factors and hardware failure. So for a lot of outages and incidents, they have one of these categories. And let's check outage into dynamics, because if we talk about some incidents, then you have some different timeline. So actual fixing take only small part of your incident. The main timeline you can see as detection when you need to catch that your system had problems. It's investigation where you need to understand where you have a problem, in what side. Some sort of escalation communication, which means that you need to contact with some team who is responsible for that if this problem is quite complex. And fixing actually takes not so much time from overall incident time. And why it is this important? Because if you reduce any part of this timeline in detection or investigation, it leads to first significant positive financial impact, and which is much more important, it's about credibility of your customers, because you can detect problems before your customers will do. And for a lot of guys, for a lot of teams who are working in the DevOps fields, or for example operations, it means that they became more happy because you reduce some toil or some problematic or routines from their work. And let's start from metrics, because this is quite effective way how you can understand or get information from your system dynamics that you have a problem. So as I said, it's almost impossible to operate on billions of metrics, and if we want to detect some outliers, then you will always have some sort of that, because it's statistics and amount of factors which affect your system in production is usually related not only to software development but to real problem cases. And it means that not all outliers should be triggered, should trigger alert, or should be flagged as some sort of incident. Here is quite a good case of HCKL project which was closed, but they have they have this project running almost 3 years. And what they do, they collect around 200,000 different metrics from their production servers. And then they try to find some sort of outliers using some fancy math algorithms. And they failed because, again, if you have a 200,000 statistical metrics, you will always have some outliers, some sort of deviation in every tick. And this is a slide from Etsy presentation from Andrew Clegg. And here is quite good lessons which they learned from the Kale project. And here is quite cool description that anomaly detection is more than just outlier detection, and one size fits all approach probably won't fit at all. There is no free lunches, and there is no some general solution or case or algorithm which fits everything. And possible approaches which they found that alert on anomalies in business and user metrics only. And here is quite important. Why? Because the question was that we have so-called different levels of metrics. We have some low-level one, which is regarding our infrastructure, some application level one, and high-level one, which is related to business and operation. And the virtualization, containerization, and orchestration frameworks are responsible for paradigm shift, for providing computational resources, handling failures, and you don't need to focus to have so much attention on infrastructure low level, and moving toward abstraction from underlying hardware and networking means that we need to ensure that our application work as intended in a sense in context of our business. It means that we need to focus on the so-called Kpi metrics, which means that for these so-called business-specific metrics, it could be logins, it could be sign-ups, it could be some transactions amount different, it could be anything which is related to specific business cases. As I said, Kpi metrics are related to the core business operations, and if we talk about the data or operations related to human behaviors, then they are usually heavily seasoned because we as a human beings are active in the day and sleep in the night. And if we take anything from sales in some shops or car sharing rides, then they have usually some sort of seasonality. And static thresholds do not work here because you will always struggle between different level of activity, like in the day or in the night. So this is a solution which is quite common if we talk, for example, if we see, for example, Prometheus. Prometheus system have, for example, you have a multi-cluster deployments, and you need something that collect your data from example, from every cluster of Prometheus and collecting in some sort of service central operation. For example, in Prometheus ecosystem, there is a solution called Thanos, where you can aggregate or make some reduction reduction of your data in some central view. And in our case, it was quite similar because we have some sort of solutions on a different side, on local sites, every team have some sort of solutions they build, and we have the same approach. We collect the data from the local data centers or deployments into the central storage. And this is so-called push versus pull approach, because in a local way, push is more effective, because you probably can have some containers which create and die, and in that case, push models is more effective, because immediately, for example, as new service up and running, then it can send metrics by itself. You don't need to set up every time some new scrape URL and so on and so on. But central pool means that you have always the control on your data. So you have no risk of overflooding your system, and you can have some fine granular logic in aggregating your data. And on top of that, it's easier to build something. For example, we create a machine learning-based solution which can operate on your metrics without human intervention. I'm just make some short intro. We have a system which creates an ensemble of models of metrics behavior, and based on that, it can tell whether you have a problem on logins layer, on signups, or some payments, and so on and so on. And again, if we talk about the system dynamics, then usually all problems have some sort of connection, because if you have a login service failed, then some open sessions is still active, but your activity became to decrease in some slower pace. So here is the results which we had. The red area is customer detection. It means that we have here this percentage of every incident or outage, we get information from customers, which is worst situation ever. And again, we talk about the credibility. And the green area is about monitoring. Violet one is our observation. What does it mean? You can see the orange line, which means that here was started solution which collects information from the local deployments, from the local data centers. So we have like a central view, finally. And you can see that amount of our observation, so it means toil. It means people in operation teams just using their eyes and some simple sort of threshold alerting maintain the monitoring, which is not good. And the green line is about when we pushed the machine learning-based solution into production. You can see how reduced the customer detection. It almost dropped to some percents, and how the monitoring percentage increased. It means that now our customers, when they have a problem, we bring information to them that, guys, you probably have problem here, here, and here, and not vice versa. Because as you can see, before that, a lot of problems, we get information about that from our customers. And yeah.
I have a question. If you go back to that, can you tell me what happened in quarter one of this year, before there's a huge drop?
Where?
Quarter one of this year.
It was drop and then increase.
Because again, we pushed the machine-based learning solution, but you do not start with everything. You start with some small subset, which is like, for example, which is easier to cover, and for example, which brings you more benefit. And again, for for a testing of hypotheses, because again, the main problem is in for example, some monitoring or observability, it's false positive amounts, because again, it's very easy to set up everything, but it can look like boy screaming wolf every time, and when wolf really come, nobody believes it. And this is it's quite harder to fight with those false positive than set up those kind of solutions step by step. If we talk about the Google experience, Google have a series of books too, which is related to site reliability engineering. And in the last one is like a workbook. They also mentioned that you need to start with small things. Okay, we have some incident which didn't cover, so we added this. And not like we are starting to write everything just in case. And usually it leads to some amount of noise. And if we talk about the general view, we are looking for anomalies on metrics, but if we are going higher, we begin to look for some regularities. For example, we can combine different events. For example, we know about some changes, deploy, and so on. So we can, for example, if we have an incident and we have some deployment events before that and some sort, then we can correlate it. Or, for example, we can put together information from traces. So it means that if our metrics solution brings to us very fast detection of a problem, then using and combining with traces means that you can make shorter your investigation part, because you can see where, for example, your problem could be. And again, if we talk about observability, this is about when you correlate different kind of information and you infer value from it. And why we need time series storage? Because there is a problem if you operate on a worldwide, then you usually have some unpredicted delay on networking. And especially if you operate on a different continents like Asia or America, then you will have quite often some problems on networking side. And again, you have some problems which is related to cap theorem. You can receive signals from the past. For example, you will have some networking, another problem, and then after your connection is restored, you will receive signals from the past. And it means that if we receive signals from the past, that we need to look into the future, because we don't know whether this signal or event was from the past or from the current timestamp, and how this window into the future, how long it should be. And why not Kafka and classical streaming? And I'm talking here only for storage of events, because again, if you build some sort of stream processing, you will have some sort of Kafka or message queues between them. Frameworks like Stormflink, again, oriented on tuples, not like specific time series data. And which is more important, we don't need to process everything. For a lot of cases, I don't know, 90% of data is not interesting. We only need, for example, to get this data only when we have some sort of problem and we need some additional information or some context which we want to bring. It is okay to lose some sort of signals in favor of performance. It is okay, because if you have some sort of problem, you will, the amount of signals is quite high. It's okay to lose some of them. And again, we have still have signals from the past. So here I want to talk about the InfluxDb, which is right now #1 time series database, and it has it's quite mature. It has a great community, and it has a quite good performance. It has a good performance. And this year, Influx version 2.0 will be introduced. Right now, it is in an alpha stage. But there is quite significant changes. One of them is Flux, which is already introduced, but Flux is more central in Flux version 2.0. This is query language, which has oriented on declarative, oriented on stream processing, and I will show it. It has a better resolution, and what's more important, Influx version 2.0 supports as a backend for traces. You can store some events from your organization, and you have, for example, you can store metrics as well. So you have the one storage for important data, and it's quite easy to combine everything. And Flux has the same streaming paradigm because you can describe your pipeline in a functional way, and then you have the same approach in architecture, and this is quite easy in the sense of paradigm to understand and to build some sort of solution. So one more. If we talk about the observability, it's about combining different sort of information from your system dynamic behavior. And if we talk about the metrics, it's about the finding some anomalies on a lower level. But again, it's not about that every outlier should raise some sort of alert. You have some sort of tracing, you have some sort of events, and you need to find regularities between them. You can build topology of your services, of your operations, etc., etc. And some say, we have a new fancy term coined, IOPS, but yeah, you can call it that, but again, it gives the possibility to understand what's going on, and if you have a problem, to get fast information about the possible problem. For example, open tracing. This is API, which will be closed in November, and I will talk later about that. But again, tracing is a more higher resolution of your system dynamics, and traces can show you information about unknown unknowns, and which is quite important. And traces will help reduce the investigation part because you can pinpoint quite fast a possible problem. And there is a quite good open source implementation of open tracing, which is called Jagger, made in Uber. And Influx 2.0 is supported backend storage for that. Here is just a real prod case with the Influx 2.0 as a backend storage. It's about 9,000 different traces per minute, and we have here performance with I/O operation and a lot of context switches as well, which brings some problem on performance. And in case of traces, it's the same situation as with metrics. You don't need to. It's not like all or nothing. It's easy to start with some smaller parts. You can cover some probably important steps in, for example, login service, or where you can have some problems. And starting with small is quite easy and quite cheap. If we have a storage for events, for traces, and for metrics, then it's possible to use some sort of transformation for finding problems. And again, it's quite easy to have some sort of functional combining paradigm and combine information from different sources, different parts. For example, here is a real incident. This activity, which has statistical regularities, if we have some larger picture, then we can see that it's begin to raise and begin to decrease in the night. And here is we have a drop-in activity related to login service as well. But for operating on those kind of data, you need to store some sort of statistical models or to have some information about your system behavior. The same part of this incident on login's part as well, drops. So again, if we, because different kind of metrics has some correlation between each other. For example, if we check here logins and activity from the same servers, we can check the relation between them, and this relation will reduce so-called seasonality of your data. And we can see here that these time series look more stationary than time series which we take per se, for example, logins and activity. And it's easier to model. Why? Random walk, quite easy, quite famous process, or Drunkard's walk. In a process where you have a lot of random factors, where you have a lot of independent factors, you can model those kind of processes using a random walk approach. When you have, for example, you can see here that current value could be modeled as a previous one plus some error or randomness factor, and it means that gives you a much powerful approach. For example, you don't need to have a statistical models, and you just can have some sort of reservoir with your randomness measurement and check for changing on that part. So if we talk the same metrics, then we can see that if we want to check randomness factor, we can subtract two previous values from each other. And this actually is a discrete derivative of those metrics because we have equal intervals. And you can see how incident looks here or on a larger picture. We don't need to have statistical models. We don't need to have some large models in that case. We just can measure randomness. And again, it's simple, fast, and using Flux language approach, it's easier to test those kind of hypotheses, and it's easier to get your data from the database side already preprocessed. So you don't need to have a,
yeah, one comment. In the beginning of the talk, you said there is no universal model.
No, absolutely not. So this is, for example, it's okay if you have a quite data metrics which is quite large. When you can operate on some hundreds, 500 something. In case of metrics where you have, for example, 1, 2 events in a minute, for example, or sometimes no, this will not work because it's hard to make a distinguish. And there is another approach for that cases. So again, it's about for finding the best approach in that sense that you can get your result expensive or cheaper. So you can operate faster, or so it's again it's up to us and our experience to understand which type of metrics, especially if we talk about the KPIs, is more related to some cases. Or for example, another one, security case. If we for example observe only failed some login increase by different causes, for example, some technical error or some, for example, incorrect password or some script key you want to enumerate you, then usually have some sort of threshold statistical one on a failed logins won't work. Why? Because in case of increased activity, people make typos. So you will have, inevitably, you will have some statistical increase in failed logins as well. So using even some sort of statistical one approach, you will fight with false positive. So you can actually, again, observe some relation between metrics, between, for example, failed login count and successful login count. And so you can, in a normal case, you usually will have some sort of flat line. In sort of some incidents, you will have quite large spikes on this side. This is, again, this is real attack on login service, which was detected by system. In our case, using just this approach with a relation of different kind of metrics. So again, if we combine all together, I'm not talking about logs because again there is a lot of solution for logs, and in case of large organization, central log aggregation sometimes is not so effective. Because again, if you have a lot of data centers and you need to aggregate everything, a modern system generates a huge amount of logs, and you will pay for traffic, you will need additional storage, and so on and so on. So sometimes problems with logs is solved differently in a different organization. So the easiest way to start with is to have some sort of metrics, traces, and events. And adding traces and events can reduce significantly investigation part, whether metrics can reduce the detection part as well. And this is combined all together can pinpoint your possible problem quite fast. And in our cases, for example, we also talk about the semantics, because if we have the similar naming in our services, in our operations, in our metrics, in our traces, then we can easily combine all together. For example, this is our obfuscated graph of some deployments and receiving events or information from the metrics part that we have some problem. We can derive in this structure, for example, what can be affected, whether we have some additional information on the service related, and so on and so on. And again, because for 90% of information, it's boring. We don't need it. We need it only on demand. And it is also quite common approach using some sort of graph engine, which creates some topology based on your data. And we actually begin to rewrite our system, because initially it was written in a Python set of services, which was made initially as a proof of concept. There was some design decisions, so it's working in production right now. So we have our production operation on top of that. But this is a redesigned system we rewritten in Java, which have some more general approach. A lot of people from different companies is involved in it from the beginning, and we are planning to make it open source, because again, if we talk about some commercial solution, for example, oriented on metrics, some like Anadot, it's expensive, it's inefficient, and it has some problem related to the system, to online learning system, which has own flaws. And we plan to make it, I guess, autumn or in the beginning of the winter. I told about the open tracing, that this will close this November. Why? Because two standards, open tracing and open census, are merged into one standard, open telemetry, which is cloud native foundation sandboxed in May. And in the roadmap, open tracing will be closed in this November. And this is okay, because it means that industry moved to one standard. The commercial solutions, for example, Instana, Datadog, they have an agent for collecting data. These agents are mid-licensed. It means that if you have some sort of engine that can operate on some open tracing or open telemetry data, then you can use those agents as well. And it means that a lot of different solutions begin to speak using one language, which is cool. But right now there is implementation of OpenTelemetry in Java, and there is bridges ready for different languages. And I guess September, October will be published other OpenTelemetry drivers in a different language stacks. So this was actually quite a fast intro, because there is a lot of problems related to that, and which more important, and a lot of pitfalls here, and a lot of companies. I saw a lot of companies which go into these pitfalls. For example, Uber. For example, we have some local companies, and I have some examples from the UK companies as well, where it's common to develop anti-pattern within, I don't know, 1-2 years, and then after that begin to question itself. Well, do we need everything? Do we need this? Do we need that? And so on and so on. So if you have questions.
Last slide, the architecture picture. There was a custom-made rules engine.
Yeah.
Have you tried also InfluxDb's capacitor module, and what do you think about it?
Yeah, we tried to capacitor, but there is problems with the capacitor. For example, if you want to use your, for example, user-defined function, because the original capacitor has some limited amount of functionality, because you can have some counts, you can work with dynamic thresholds. It means that if you want to implement UDF, you need to write it in a Python, which will run in separate process. If you have thousands of metrics, which needs, for example, some, I don't know, tens or hundreds, some user-defined functions, you need tens or hundreds like processes. And in Influx 2.0, there is no capacitor. So everything is combined together, and there is tasks. There is some sort of alerting came from capacitor, but again, it has some limited functionality. So you can have some alerting based on combining your Flux queries and so on and so on. But in case of working with some statistical models, you can implement this functionality, but it will be quite ineffective. Yeah, time tricks.
Time tricks. Okay.
We have a landing. I forgot to put. timetricks.io. So we have some information put here as well.
Any more questions? Right. You made it so clear this time. Thank you so much, Aleksandr. This is to you. Well, best of luck with shipping.